Balancing equations. So we represent a chemical reaction with a chemical equation. So for this reaction, we have some solid magnesium combining with some oxygen gas to give us the compound magnesium oxide. So we have our formulas for all of our substances, our two reactants, and our one product. So we need to balance the equation such that the number of atoms on the left of the arrow equals the number of atoms to the right of the arrow. Law of conservation of mass, whatever we start out with, we have to end up with. So the way we're going to balance equations is we're going to write the symbol for each element underneath the yield sign. So for this we have magnesium and oxygen. Then we're going to do an atom count on the reactant side. So I have one magnesium atom and I have two oxygen atoms. On the right-hand side of the equation, the product side, I have one magnesium and one oxygen. And now I need to balance this so that I have the same numbers on the left as on the right. Now, one thing I cannot do is just add a 2 here because that would change the formula, and you cannot change the formulas. To balance the oxygen, now we have to use coefficients. So I need two oxygens. I'm going to put a 2 in front of the MgO. And now I have to update all my atom counts that are affected by putting in that coefficient. So that gives me 2 magnesium atoms and my 2 oxygen atoms. So the oxygens are now balanced. However, now the magnesium is out of balance. I need 2 magnesiums on the reactant side, put in a coefficient of 2, update my atom count, and now I have 2 magnesium on each side, 2 oxygen on each side. I am balanced. Okay, so let's try another one. So now we have aluminum oxide, Al2O3 solid, producing aluminum solid plus oxygen gas. So again, we'll put our elements underneath our yield sign, aluminum and oxygen, and then we'll do our atom count. So we have 2 aluminum atoms and 3 oxygen atoms on the left, and we have 1 aluminum and 2 oxygen atoms on the right. So here I see that my aluminum is out. I want to have 2 on this side, put in my coefficient, and update my count. I look at my oxygens. The oxygens are not balanced. When I have this 3-2 situation, what we're going to do is put 2 over here to give 6 oxygens and 3 over here to give 6 oxygens. All right, so I'm going to put a 2 in front of this, and that is going to change my aluminum count to 4, and then my oxygen count to times 3. I get a total of 6 oxygens. And then I said I'm going to put a 3 over here. 3 times 2 is going to give me 6. So my oxygens are now balanced. I recheck the aluminum. I have 4 here. I need 4 over here. So I'm going to change that coefficient to a 4, and then I can change this to a 4. Now I have 4 and 6 balanced. I'm just going to rewrite that equation so that I don't have any scribbles or crossouts in it. So 2Al2O3 yield 4Al plus 3O2. And you also want to check your ratio of your coefficients to make sure they are in the lowest whole number ratio. And 2 to 4 to 3 is indeed lowest whole number ratio. Okay, so our next example, we have iron and sulfur making iron sulfide. So this one is going to be pretty easy. All right, so we have one iron, one Fe, one iron and one sulfur. And on the right, we have one iron and one sulfur. We are balanced. That equation has all 1s for their coefficients. And usually when the coefficient is a 1, we do not actually write the number 1. it is understood that you have one of those particles. So that equation is balanced. But I do want to mention something when you have sulfur. So you might see the equation this way: iron solid, Fe solid, plus S8 solid yields FeS. So sulfur exists as a ring of 8 sulfur atoms all bonded together. So sometimes in equations, sulfur is represented with just the S, and sometimes it is represented as S8. So it doesn't matter, we're just going to go ahead and balance as normal. So in this case, we do the same process, Fe and S, but here we have 1 Fe and 8 S. Over on this side, 1 Fe and 1 S. So we need 8 sulfurs, put in a coefficient of 8. That gives us 8 iron atoms and 8 sulfur atoms. So the sulfur is balanced, and now we just need to balance the iron. I need 8 iron, put in my coefficient of 8, update my atom count, 8 and 8, I am balanced. All right, for our next equation, we have an equation involving a polyatomic ion. So we're going to be able to use a nice shortcut for balancing this type of equation. Okay, so we write down our element gallium, Ga, and then we have lead, Pb, and we are going to balance the NO3 as a group. It's NO3 in parentheses on this side, NO3 in parentheses on that side. We're going to balance it as a group. That is going to just make our job a lot easier. We don't have to. You could balance the nitrogens and the oxygens separately, and you'll get the same answer, but this is definitely an easier way to go. So we have 1 gallium, 1 lead, and we have 2 NO3 groups on the left side, the reactant side of the equation. On the product side of the equation, we have 1 lead atom, 1 gallium atom, and we have 3 of these nitrate groups. So the gallium and the lead are okay. Now we have this 2-3 situation. So remember, we're going to cross over and put 3 here and 2 here. And then we go back and change all of our atom counts. So now we have 3 lead on this side. And 3 times 2, 6 nitrate groups on this side. All right, we have to do the update count for this compound because we put in a coefficient. So we have now 2 GAs and 2 times 3, 6 nitrate groups. So that's great. So that balanced out our nitrate. Now we go back. So for the Ga, we have 2 over here. We need 2 here. Put in a coefficient of 2. Update our count to 2. So that's good. And now lead, we need 3 over here. Put in a coefficient of 3. Update our count. Do our check. 2, 3, 6. We're balanced. Check our coefficients. 2 to 3 to 3 to 2 is lowest whole number ratio. So that is a good balanced chemical equation. Okay, so now we're going to do another one of these where we can balance as a group. So we have the calcium, Ca, the chlorine, Cl, the sodium, Na, and here we have PO4, and here we have a PO4 group. So we're just going to put that in parentheses. It doesn't matter if we have parentheses or not. This would be the same as having a subscript of 1, which just means we have 1 phosphorus and 4 oxygens. So we're going to balance that as a group. Just makes it easier. All right, so now we do our count. On the left, we have 1 calcium, 2 chlorine, 3 sodium, and 1 PO4 group. On the right, we have 3 calcium, and we have 2 PO4 groups, 1 sodium, and 1 chlorine. Okay, so we need 3 calciums over here, so we put in a coefficient of 3, which gives us 3 calciums, and 3 times 2, we get 6 chlorines. Okay, So the calcium's good. Now we can do the chlorine. We're going to need 6 chlorines on this side. So put in our 6. That gives us 6 sodiums and 6 chlorines. Okay, so calcium is good, chlorine's good. Now the sodium, we need 6 sodiums over here. So we have 3. To get 6, we're going to put in a coefficient of 2. 2 times 3 gives us 6 sodium. And this gives us 2 phosphate groups. So now we need we're good. 3 calcium, 6 chlorine, 6 sodium, 2 phosphate. We are balanced. Check our coefficients. 3 to 2 to 1 to 6 is a lowest whole number ratio. Awesome. Okay, so here we have our Bunsen-Burner reaction. So CH4, this is methane gas or Bunsen-Burner fuel. It combines with the oxygen in the atmosphere. We get it going with the butane lighter, and our products, when we have that good, nice blue flame, are carbon dioxide gas and water vapor. Now, there are a lot of equations involving carbon, hydrogen, and oxygen. I call them CHO reactions. And it's a good idea when you're balancing these, we're always going to do the carbon first, then the hydrogen, then the oxygen. You definitely want to balance the oxygen last because it's showing up in 2 places in the product. So we have to be mindful of that. Okay, so we have 1 carbon on the reactant side, 4 hydrogens, and 2 oxygens. On the right, we have 1 carbon, we have 2 hydrogens, and we have 2 plus 1, we have 3 oxygens on the right. So we're going to worry about that last. So carbon's good. Now we do hydrogen. 4 here, we need 4 here, so we're going to add a 2 in front of the H2O. Update all of the atoms that are affected. So 2 times 2, we have 4 hydrogens. And now we have 2 oxygens plus the 2 in the carbon dioxide for a total of 4 oxygen atoms. Now we need to balance the oxygens. We have 4 on this side, we need 4 on this side. So we put in a 2. 2 times 2 gives us our 4. And carbon, hydrogen, and oxygen are all good. Our ratio of our coefficients is 1 to 2 to 1 to 2. Lowest whole number ratio. We are balanced. All right, and for our last reaction, we're going to do another one of those CHO reactions. You'll see that we have oxygen as a reactant and carbon dioxide and water as products. This is called a combustion reaction, and our Bunsen-Burner reaction is also combustion. Anytime you have fire, it is a combustion reaction. All right, so carbon, hydrogen, oxygen, it's CHO. So on the left, we have 5 carbon, 12 hydrogen, and 2 oxygen. On the right, 1 carbon, 2 hydrogen, 2 plus 1 is 3 oxygen. So we're going to do carbon first. So carbon, we need a 5, put in our coefficient of 5 and update all the atoms affected. So we have a 5 for carbon, and now we have to update the oxygen. So 5 times 2 is 10, plus 1, we have 11 oxygens on the right. Now we're going to move on to the hydrogen. So we have 12 over here, we need 12. So to get 12, we're going to put in a coefficient of 6. 6 times 2 is 12. And now we have to update our oxygen. So we have 6 plus 10 gives us a total of 16 oxygens on the right. So now we need to get 16 oxygens on the left, put in an 8. 8 times 2 is 16. And now we have 5, 12, 16. We're balanced. Our ratio 1 to 8 to 5 to 6. And we're good. And that's it.